Hey guys, I wanted to take a quick second to go through a few more examples of finding domain and range from a graph. I'm getting several questions from students about this specific part in the homework, so I just wanted to make more examples, if you will, in the video since we don't do a ton of them in class. So with domain and range from a graph, just a few things to remember. With domain, it's always the x values, and so x values are of course going to be on my x-axis, and so the x-axis is the horizontal axis, which means for my domain I am looking at where is the furthest left point to where is the furthest right point. Range is going to be my y values, so the y-axis, which would be the bottom, or how far down does my graph go, to the top, how far up does my graph go. Something that I sometimes do in class when we have time is we will actually cut out strips of paper or use popsicle sticks to make these two things that I'm going to use for highlighters. So what this is, if you want to do this, if you like what you see in the video and you want to make your own, you're just going to get out 2 strips of paper, cut them vertically, write domain on them just like I have on the left. Cut 2 more strips of paper, lay them horizontally, write range on them, just like I have on the right. With these, I have been seeing a lot of people getting the order confused. If you write them in this correct order, it will always be least to greatest. So your quick check for this is the least or the smaller number on the left is the greater number on the right. And so you're going to see in the examples, I'm going to use these 2 things, the 2 bars, if you will, to kind of help us through this these examples. So here's my first example. First example is a circle, and I am looking for the domain and the range of this graph. They didn't give me the equation, they just told me, here's the graph, find the domain and range. So if you have the strips of paper, if you made those, I need to lay the 2 vertical papers as far left as the graph goes, which is right here, to as far right as the graph goes. So I have those 2 pieces of paper, strips of paper, or popsicle sticks, literally sitting in that exact spot as my highlighted area. Now on the x-axis, that is the point, or not the point, that is the spot -3 all the way to the spot 5. And so my domain is going to be -3 to 5. Now pretty much always for us it's going to have brackets, and if you remember back from inequalities, brackets meant that it was included in the graph. And as you can see, at -3 and at 5, there is a part of the graph there. It is a filled in continuous graph. With the range, I'm going bottom to top. So get out your other 2 strips of paper or your 2 popsicle sticks. The bottom of this graph is going to hit right there. The top of this graph, right there. So bottom to top, where I want to write it in that order, the bottom of the graph is going to be at the point, at the y-axis at 1. The top of the graph is going to be at the y-axis at 9. So my my range is going to be bottom 1 to 9. Again, I've got the brackets because there are actually physical points on my graph at those spots. Okay? All right, example 2 is now very similar to example 1, except it's a half circle. So they've cut the top of my circle off. I'm still looking for domain and range. So domain, I'm going from left to right. So I've got my popsicle sticks or the strips of paper. The furthest left point is right there, and the furthest right point is right there. Now I need to find what does that correspond with on the x-axis. So on the x-axis, that is at 2. And on the x-axis, that one is at 8. And so my domain from left to right is 2 to 8, both with brackets because those are actual points on the graph. Range, bottom to top. So I'm going to get my popsicle stick, strips of paper, whatever. The bottom of the graph is right there. The top of the graph is right there. So bottom to top, well, the bottom is hitting at -8 and the top is hitting at -5. So my range is going to be bottom -8 to top -5. Okay, example 3. Example 3 is some strange looking graph. I'm looking for the domain and range. Now this is the first time we're seeing the arrows in my video. These arrows mean that this graph is going on and on and on and on forever. So it just keeps going off the graph forever. So my domain, there is nowhere, if I were to take my yellow stripe, if I put my yellow stripe there, well, the graph keeps going to the left forever. So to the left forever is actually -infinity because it keeps going. That's what that arrow means. That arrow means it goes to the left forever. Well, same thing on the right. If I were to put my popsicle strip here, well, it keeps going. So there's nowhere that I could put my popsicle and actually be at the end of the graph. And so it keeps going forever. So we call that positive infinity because it is going to the right. If you remember from class, from when we were doing inequalities, the infinities always get parentheses because you cannot ever get to infinity to include it in the graph, to close it off. All right, let's look at the range now. So the range, I'm going from the bottom to the top. Well, this graph over here, it keeps going further and further and further down. So my range is actually going to be -infinity because it keeps going down. The bottom of the graph is forever. Same thing with the top. Because that arrow keeps going, it keeps getting higher and higher and higher. The top of my graph, or the range, is -infinity to infinity. So both for this one, the domain and range were -infinity to infinity. This is also called all real numbers. You can use either one of those as your answer. My last example, this is actually called a parabola. You'll study these in Math 102 and Math 110, but for now, we don't care. We just see the shape of this graph and the directions say find the domain and range. So I've got my 2 popsicle sticks, strips of paper. Again, I've got these arrows which say forever, forever. It just keeps going and going. So if I were to put my popsicle sticks on here, well, the graph at some point would be wider. It'd be further down, but the graph keeps getting further to the left and further to the right. And so I translate that in math to be -infinity to infinity. Because it's got those 2 arrows on the end, it's going to keep going further and further to the left. And because of this arrow, it's going to keep going further and further to the right. Now I'm going to look at my range. My range is always bottom to top. And so the bottom, if I were to put my popsicle stick there, well, those arrows tell me it's going to keep getting more and more negative. It's going to keep going down. So the furthest point down on this graph is actually going to be -infinity because it keeps going down forever and ever and ever. Gets a parenthesis. The highest point on my graph is going to be right here at -2, and because there's actually a point on that graph, it is going to get a bracket. I hope this video helped to kind of sort through some stuff, but as always, if you have questions, let me know.